Hello Abaqus user, welcome to Abaqus Acumen for quick and sound learning. Today's session we are going to do on a composite heat transfer problem. So we have like a brick wall and that have insulation on the both side, and there is a high temperature of 150 degrees C on the wall one side and 10 degrees C at the other side, and we want to map what is a temperature distribution across this wall, and we are specifically interested in how is the interface temperature. So this is the problem what we are going to do. This we are taken from MIT education course on aeronautics, and this thermal engineering lecture notes we are taken, and that's where you have this problem of insulation and the heat transfer through this composite wall, and through closed form solution they measure what is the interface temperature, which is nothing but 90 and 70. We'll try to solve this problem, and this is how the pre looks like. So you'll try to model this as a solid. Will have heat temperature. This is temperature applied on the one side 140 and 10 degrees C, and that's what actually we'll try to do. So if you open Hypermesh preprocessor version 13, you go to the preference and first select the user profile Abaqus 3D. So we'll just quickly show you before going to this how it looks in. So this is our the fifth tutorial in Hypermesh preprocessor Abaqus tutorial. We are going to do conduction heat transfer through the composite wall. So this will be like our 106th video on Abaqus solver. So let's look into what other things, how it the problem looks like. So as I mentioned, it's a heat transfer through composite, so the conductivity of insulation is quite low, it's 0.07, and conductivity of brick is 0.7, and we'll measure what is the temperature at the interface. So overall, if you see this problem, this is actually conduction, so your heat transfer is minus Ka dt by dx. So temperature gradient across the thickness, and then you have cross sectional area and the conductivity. So if we are only solving the conduction problem, we are not taking convection or radiation. So this is the first conduction problem. So we'll apply the temperature boundary condition here like 150 degrees C, and then other end it will be like 10 degrees C, and we want to measure what is the interface temperature. We'll also try to map what is the temperature distribution across this, and we'll see how it looks like. So this is what actually we plot like 150 what it comes to interface, and then other interface, and going to 10 degree C across this composite slab. So let's start doing the problem in Hypermesh preprocessor. So let me first I'll use a function f8 and put the node at 0 0, and then I'll say shift F4 and I'll just copy the node. So we just want to have a constant cross section, so I'm going to move these around 0.1. so this will be the height what we have taken. It is immaterial, we want to just have a constant cross section and measuring heat going through the composite. I'll say duplicate, and then I'll say Y, I'll say put 0.03, so I get a first insulation thickness. I'll say duplicate these, and then I'll say 0.1, so I get another things, and I'll say duplicate, and I'll say 0.03. So if I put F4 and measure, this is 0.03 thickness, and then this is 0.1, and this is 0.03, and then I already created one. I'll create one shell, one collector. So I said 2D, I'll go to rule. Before that, I'll just see I need to put a mesh size. So you first go and put cleanup tolerance 1 e power 0.5, then you go to mesh, you put geometric tolerance to that, and I say 5 e power minus 3. That is what the mesh size what I'm looking. The units are everything in meter. So if you go to our drawing board and you see here, so it's like a meter. So it's SI unit, ton, Newton, meter, second. And the temperature boundary condition in Kelvin, but you can apply it in the Celsius. So the conversion wise there is no difference in that. Then I say 2D and I say spline, and I'll just take this node. So we put a mesh for that. I'll just copy this mesh to the other end. So shift F4, I select all this element, duplicate original component, and here I'll say N1 N2, and I'll say move this to this. So we don't have to really go and mesh it. So we got all the insulation thickness. I just want to put a mesh here for brick, so that will be shell 2. I'll choose some color. So I'm just making a 2D mesh first. So once we have a 2D mesh, we'll just along thickness direction we'll just put a 0.01 thickness and get a thickness data, thickness cross section there. Then I'll say 2D, I say rule, I say node by path. So I select first node, I select another node. So same, I select first and second, and I'll just mesh it. So we got all this geometry. Now what I'll do, I'll just make a component called insulation, and I'll select something like this, and I'll say I remove this. So I go to 3D, I'll say drag, and I say element, and I want to drag this along X and around 0.01, and we want to have 3, will say element by collector, will select this and we'll say drag plus. So we got a 3D there. Then I'll say brick, I will choose some other color, and we'll say 3D drag, we'll choose this element, and then we'll say drag plus. So they are all solid are generated, but they are not connected. So if you say F5 mask and you say element by attach, so they are still attached by shell. So if I take out the shell and then I want to connect, F5 by attach, so still there somewhere they are connected. So first we'll just merge it. So for merging, you go to tool, I go to check element, you say 3D, and first check what is the length. So length is like 0.003, but we want to just, if you have to merge it, we'll use shift F3 and we'll merge with less than the length size. So 0.01, that's what actually we'll put, and then I'll say element display, will say preview equivalence. So you see this many nodes are not equivalent. So the first node was equivalence, but the others was not. So you say equivalence, so they are merged now. Now other way to find whether everything is fine or not, you just take this all solid component, go to the tool, you say faces, and you select all the element display and find face, and then you go this faces and you may put shift F3 and say element display and say preview equivalence. You say you should get find edge, you should get this message, no edge are found. And if you put T section, you say find edge, no T section found. So everything is fine. Now we already have, let's first now put boundary condition. So you go to the material, you first say brick, and then you say Abaqus material create, and then we want to put conductivity, and so conductivity for this is 0.7. This is doesn't matter temperature, so we are not really putting temperature dependent metal property, we are just putting one property. I'll just go back and see what was the, so for brick it was 0.7, so we put for a brick, we'll just put for one for insulation, that is around 0.07, so this is 0.07, and this is also, will put 23. Now we'll just put brick, go to the section property, then you select solid section, you select material brick, and then some color whatever you want, create and edit, and then you see solid section elements at brick. So if you say no prefix for the name, it is just a matter of naming. And then insulation, and then you select the insulation one, and we don't want HM prop, so we just remove that. Now we'll just update the component with specific property. We select the insulation, and then we select the insulation one, then say update and edit, then we'll select the brick and we'll say update and edit. Also we'll rename the shell we can delete also shell component, but if you put this particular sign hyphen, then it will not export it. So if you have something like hyphen at the start, Hypermesh will not export this. So we have everything given now. We also got this cross sectional area. We'll just select the right solid element. So you go to the element edit, you go to 3D panel, you go to the element edit, you go to 2D, and then you select here is a DC3D8, which is a heat transfer solid element. So we update it. So if you choose anything, it's like small element, it's DC38. So let's put now the boundary condition. So first say temp 150, you say car, you select history, you give some, and then you go to 3D analysis, you go to the temperature we are going to put, and the nodes on plane, I'll just select this with low, and you select Y and you select this. So keep tolerance low, so it will just select that, and you put 150, and this uniform size will put 0.001, and you apply it. So it keep 150 at one end. I'll create one more temperature boundary condition, 10 degree, we give some other, and then you go to analysis, you go to the temperature, say node on plane, so you create that. Now we create the temperature boundary condition. Now we'll create one output block, and we'll put output variable equal to pre-select, and then say frequency is equal to 1. It's a linear analysis, so we don't have to really go. We'll put element output and then node output. So we're done with boundary condition output block. You go to the load step, you say conduction you select the boundary condition, you select the output block and say create, and then you go to the edit. So here you say heat transfer. So this is like it's a linear static conduction analysis, so you don't require to go to, you can have step, you can have name, and then increment is not required. So we are done with the preprocessor one. Let me save this file. So I say heat transfer. We'll export it and then we'll look into the INP file and then submit or run. And you export it, and now let's go and check how it looks like INP file. So you have node data, then you have element data, so it's DC3D8, then you have insulation, brick, solid, then you have conductivity, you given a step, then this is a temperature boundary condition. So we are good at to go. So let's go and use Abaqus command. Then I just go to the specific location where my files are there. I copy there and I say ABQ6145J is equal to HT and then interactive mode. So it will be very quick run. So you'll just have a pre-processor done and then quickly done it, and then we'll measure how the temperature distribution look across the composite wall, and we'd like to plot. So it just started, so just pick up Abaqus license. So just going to the pre stage. So I'll just close one of the Hypermesh. So we'll just wait till it is in queue, so we'll just wait till it solve the problem, and once it's solved we'll just check it. So we just finished the run, so let's plot how the temperature looks like. So I'll take ODB file and see how the temperature looks. So I'll just put in one particular view and then we'll just measure how the temperature looks like. So we apply the temperature. So if you look, you have 100. So we'll just try to plot it. So I just split this window into two. I'll just here I'll use hypergraph things. And then I'll just take temperature distribution across this. So I go to the first window, I say you go to the measure and you say add, and then you say nodal path, and then from this I'll just go to, so I just want to take this and the other end. and I'll say create curve with existing second window, and then I'll just take this window here, and this is what looks like a temperature. So we'll just put this as a temperature degree C, and this is what is thickness. So this is by distance. So and then you can measure. So if you go and measure what is here, so if you look here, it is 90 C, and then here it says 70. So you can also plot, like you can do different thing and then you just measure what is. So this is exactly what this tutorial done. So they also have like temperature drop plot. So they are put at degree 10 degrees see how it looks like. So we also got a similar curve for this. So this was a quick learning on this Hypermesh Abaqus tutorial. Thanks for watching this. Don't forget to like us and subscribe. Thank you. Bye bye.